This is part 2 of Unit 1, Lesson 1 on Introduction to Quadratic Functions. So the next big topic of this lesson is determining whether a relation is a function. So you're going to want to copy down this definition here. Okay, so a function is a relation in which there is only one value of the dependent variable for each value of the independent variable. So I understand that that is kind of a confusing mathematical definition, so you might want to just copy down what's in brackets here below. But this isn't as hard as it sounds. Basically, if you have a function, for every x value, there's only going to be one y value. So in terms of a mapping diagram, like you see below, all we need to find or determine is that there isn't two arrows going from the same x value. Okay, so if we're looking at this first one here, we can see that we have 2, 3, 4, and 5. Each of them has one arrow going out of it. Although, yes, 8 here has 2 arrows pointing to it, that doesn't matter. We're just worried about those x values. So this is actually a function. Okay, this other example here on the right is a bit different, right? We can see, if we look at the number 4, that we have 2 arrows going from it. We have the point 4,1 on this line, and we have the point 4,8. So this does not satisfy our condition that every x value has only one y value. 4 actually has 2 y values, so this is not a function, or we call it a non-function. Okay, so another way to figure this out, if we have a graph, is using something called the vertical line test. So you're going to want to copy this down as well, or at least know what it means. So on a graph, if a vertical line passes through the line or curve in more than one location, then the relation is not a function. So if you look at this example below, we can see that this red line crosses our curve in 2 spots. So that means it's not a function. It's as simple as that. If it crosses in more than one location, then it's not a function. So we can just say not a function because it does not pass the vertical line test. Vertical line test. Okay, so that is not a function. Let's look at a couple more examples. So it asks us to state whether each relation is a function, as well as stating the domain and range for each. So let's start with function, whether it's a function or not, because that's pretty easy. So all I need to do is my vertical line test. Remember, vertical is up and down, so I'm just going to draw a line. I can see that my line is only crossing this relation once, so that means it's a function. Simple as that. This one is a function. Okay, now let's take a look at the domain and range. Remember, your domain is your x-axis, and your range is your y-axis. So we can see that our line here, or our parabola, has arrows on the end. Okay, so again, try to isolate x in your mind. Cross, like with your fingers, cover up the y, because you're not worried about the y right now. We need to know that if I asked you to give me a value of y for the x value negative 256.6, the question is, would you be able to give me a value for that? Well, yes, you would, because these arrows on this line, although they're going up, you have to remember, as they go up, they're also going out. So that means that for every single x value, there's a y value. So you'll remember our notation that we use here is x is equal to all real numbers. Okay, and that's all we have to write. That's it. Our y, on the other hand, so we're just looking at the y again, it might be easier if you just take your fingers and cover up the x-axis. So you remember, you're just focusing on y. So we can see that on the y-axis, if we draw ourselves a little line, we can see that this function is starting at -4 and going up. So we just have to figure out how to write that mathematically. So we're dealing with y, okay? And the next thing we need to figure out is y greater than or is y less than? Well, think about it. It's going up, right? So as we go higher on our y-axis, we get larger. Our numbers get larger. So that means y is greater than or equal to, because we can see that there's a point there at -4. -4, right? Because that's where our line started, and we're just going to continue up for infinity. Just going to keep going. That line's just going to keep going up, which means every value of y that's greater than -4 will have a value of x. Okay, second example. Let's go back to determining whether it's a function. So again, the first thing we need to do is draw a vertical line. We can see this is crossing in two spots. That means it's not a function or it's a non-function. So I'm just going to write non. Okay, and then again, domain and range. Domain. So first we're looking just at that x-axis. So I can see on my x-axis, this actually is starting at 3, right? If I asked you for a y value at -3, you wouldn't be able to give me one because it doesn't start until 3. So it starts at 3 and we have arrows on both ends. So that means it's just going to keep going to infinity. So my domain is going to be x is greater than or equal to 3. My range, on the other hand, again, I'm just looking at my y-axis. So I can see that there's arrows on both ends. So there actually isn't a start point and an end point to this, which means y equal to all real numbers. For any value of y, I can give you a value of x, okay, because it's just going to keep going. Okay, third example. So first we're going to look if it's a function. So we draw our vertical line. We can see it crosses in one spot, which means that it is a function. Okay. Now, again, looking at our domain and range. All right. So, domain, x-axis, completely ignoring our y-axis. We have to see where our line starts and where, if it does, ends. So I can see, I'm going to draw myself a little line down. I can see that my function starts at -3, and I look, and it doesn't give me an endpoint, right? That arrow indicates that it's just going to keep going. So that means my domain is x is greater than -3. And again, greater than, because think about your Cartesian plane, how you graph. These numbers, as I move to the right, are getting larger. The reason it's not greater than or equal to is because I have that open circle, right? That open circle means just greater than or less than. My range, on the other hand, I'm looking at my y-axis. So I want to know where my line starts on my y and where it ends. So again, I'm going to draw myself a little line to my y-axis. So I can see that my line actually is starting at +7. And again, there's an arrow on the end, so there is no end point. So this is just one condition again. So y has to be, again, that's an open circle. Oh, let me go back to my correct color. So because it's an open circle, that means it's not equal to, it's simply just less than 7. Again, less, because you can see the arrow is going down. Okay, a couple more examples here. I know we have a lot of examples in this note, but it is kind of a tricky concept, and it's something that we'll use throughout the whole course, so I want to make sure that you have a good understanding. 2 more examples, and then a quick summary. All right, so number 4 here. First thing we're going to look at, is this a function? I draw a vertical line. It only crosses in one spot, so that is a function. Domain and range. Domain, looking at my x-axis. Where does it start? Where does it end? Okay, well, I can see this line or this equation has actually a start point and an end point. So that means it's going to be one of those dual conditions. So I'm going to start by just writing x and point my arrows to the left, okay, because I know that's the notation. And I know now it's pretty easy for me. I have to fill in my lowest number on the left and my highest number on the right. So I'm looking at my x-axis, so I can draw myself a little line. These points are actually labeled, so I don't necessarily have to. But I can see that on my x-axis, I'm starting at -5. Okay, and that's a closed circle. So that means greater than or equal to. And I am ending at 11. Okay, and that's an open circle, so it's just greater than. Or actually, it's just less than. So let me check my notation, make sure that this line satisfies what I wrote for my domain. So x is greater than or equal to -5. That's true. And x is less than 11. Also true, so my domain must be correct. Now I'm going to look at my range. Again, completely ignore the x, you're just looking at the y. So same notation. Obviously, this is going to be a dual condition, so I'm just going to write in with my blanks, right? Technically, these are blanks that I'm filling in. So on my y-axis, I can see that my line goes from, I can draw my little lines here, -9 to +7. -9 is obviously smaller than 7, so I'm going to fill that in here on the left side and 7 on the right side. Now I just have to double check to see if there's an equals to. So I see for -9, that's an open circle, so that's just greater than. And for 7, that's a closed circle. So I need to add my equals to on that one. Again, double check, just read it from the center out. Y is greater than -9. Yep, it is. It's above -9 on the y-axis. And y is less than or equal to 7. Yep, y is less than 7 on my y-axis. Okay, so that is correct. Now you also might see something that looks like this. So I see I have a graph here and I have a bunch of coordinates plotted. So the first thing I'm going to look at is this a function? Okay, the vertical line test might not be so obvious here, so you might have to actually look at the points. But remember, I can only have one y value for every x. And I can see that these 2 points are both 2 on the x-axis, so that means that this can't be a function, or it's a non-function. All right, so now that that's out of the way, let's look at the domain and range. So our domain is our x-axis, right, our x values. So when we have something like this, all we have to do is write out our x coordinates. So this is even simpler. So we're just going to say x equals, and then we're going to look at every coordinate. So we can see, we're going to try our best to write them kind of in order. Okay, but our x's, so we have x equals -5, -3, 2, 7, and 11. Okay, and we are done, right? It's as simple as that. For our range, which is our y values, we're just going to do the same thing. We're just going to list them out. So y equals, okay, looking at my y-axis. So I see I have a point at -6, 0, 5, 9, and 14. Okay, all I have to do is list out those values, and that is it. So that tells me that I have these x values, -5, -3, 2, 7, 11, and these y values, -6, 0, 5, 9, 14. Okay, all we have left is a summary here. Save. Okay, so just a quick summary. So this is what you should have taken out of that entire lesson. So for domain and range, if there are restrictions on our variable, we have to state the restrictions, okay? So what that means is that we just need to state how our domain and how our range are affected. So domain, again, is our x's. Okay, so I look at my x-axis, I can see that this starts at 4, and it's just going to keep getting smaller. So my domain is x is less than or equal to 4. And my range is my y's. So I can see on the y-axis I start at 2, and I'm just getting larger. So y is greater than or equal to 2. Okay, so we're just stating the restrictions. If there aren't any restrictions, which means if there's arrows on both ends, and it's a straight line, we need to use the notation x is equal to all real numbers, y is equal to all real numbers. Okay, it's not necessarily true that the domain and the range will both be equal to all real numbers, but in this case, they are. This line is just going to keep going, which means every value of x is on it and every value of y is on it. Okay, so if there are points on a graph and numbers in a table, all we're going to do is simply list them. So for domain, remember that's x, I'm just simply going to list them. So x equals 3, 5, 6, 11. Range is y equals 2, 9, and 10. Extremely simple. Okay, same thing when we have just points on a graph, right? Coordinates, we're just going to list them. So the x values here, we have x equals -3, 0, 2, and 3. And for our range, we have y equals -2, -1, 0, and 3. Okay, and those are just the coordinates of the points. If you need to, you can obviously write out the coordinates beside. So this one would be 3, 0, 2, 3, right? The x is always first. This one here is 0, -2. And this one would be -3, -1. Okay, and you'll notice that those are the same values I used on the right-hand side where we listed our domain and our range. Okay, don't worry about that homework for now. You have 2 worksheets that you will be completing, and I will let you know if there's any extra homework to go with. But that is finally the end of our first lesson.